is MARec, Metadata Alignment for Cold Start Recommendations, and it will be presented by Julian Montail.
Hello. I'm Julien Monteil. I'm an applied science manager at Amazon Machine Learning, based in Australia. I did this work while I was a scientist with my colleagues here. So at Amazon, we are lucky. We have a great ecosystem to design, to research and develop recommendation engines. We work on product recommendation, Amazon.com, in a lot of Amazon marketplaces. Yesterday we saw a presentation from Amazon Music. We do some work also on, grocery substitutions and video recommender systems. And this is some work I did while our team was tasked to develop a recommendation engine from scratch for a new streaming platform to be released in India, and now in some Southeast Asian countries. And as we were building a recommender system from scratch, right, we wanted to attract as many customers as possible and onboard as many videos as possible. So the cold start problem was a big one to address. And of course, there was also a lot of scrutiny on the work we are doing. So, being careful, the usual operational issues of recommender systems. Be careful not to overfit to the customer preferences. You can see on the right-hand side, because my son watched the Ice Age movie, we kept getting Ice Age recommendations. And similarly on the left-hand side, you can see a horror movie next to the Lion King, which seems to indicate that it's more of a popularity-driven recommender and not really reflecting the semantic preferences super well, right? So those screenshots are very old, right? They don't actually match what the current customer experience on Prime Video or Disney. So yeah, as I said, I will focus in this presentation on the cold start problem, which was essential to the research and development work we did for this Amazon new streaming platform. And yeah, basically the idea was to leverage the existing large body of literature, right, on addressing the cold start problem. And here my rough attempt into categorizing the approaches and the large literature, and I'm missing a lot, I apologize. So I guess from my perspective, for classes would be hybrid, collaborative, and content-based filtering first. And we have some, a seminal paper in the late 2000s on this. Lam et al. On adding basically a content-based filtering term as a regularization in the collaborative filtering objective. Learning attribute to feature mapping would be Gantner and Handel on for each item attribute, doing some feature imputation to project them into the collaborative filter space. And here I'm quoting as well a work on probabilistic models for unified collaborative and content-based filtering, which was one of the early work to look at the cold start from the user perspective. We have some meta-learning approaches. Dropout.net is one famous approach to improve generalization of collaborative models for cold start. You see as a meta-learning paper from Twitter, I'm quoting here. There was a recent push as well, which is the third category in this slide here, on neural land approaches. There is neural feature combiner, which is one. There is contrastive learning for cold start recommendation, CLC-REC, which aligns again collaborative embedding with item embeddings, user embeddings with contrastive loss. And there is a recent paper on building on top of it and being careful with the item feature deviations, that if we rely too much on the item features, there is, we basically train a representation on the clicks, then we are damaging the cold start performance. So there is further alignment term. The model is called equal, I think. Yeah, and the retrieval augmented architecture, which is the last bullet point here, and those are more used in the context of long tail classification and in the NLP literature, right? So, yeah, basically doing some similarity matching on top of the model and having this similarity matching branch to retrieve and classify for the underrepresented items in the vocabulary. Okay, so in the context of this large body of literature, our aim was not to, do something drastically different, but rather to build on top of what's working, right? And especially I was very careful in having one single model, right? Because as we get more customers and videos get more streams on the platform and so on, we want to maintain, 3, 4, 5 models. Ideally, we should have the same one. Maybe we can have different type of parametrization and, to serve a different model online, but still the technical debt will be reduced if we have one model handling every kind of scenarios, cold scenario, mixed scenario, warm scenarios. So, yeah, that's basically, if we do that, ideally our model should converge to the state-of-the-art literature in warm start scenarios. That was one idea. And the second one is it's important to make sure that our architecture is flexible and we are able to extract as many, we're able to leverage as many features as we can. So as soon as we have a better feature representation, we should see a lift in the cold start performance. If we add new features, we should also see a lift and so on. So no restrictions there, and we need to achieve this with the scalability constraints. Millions of customers, hundreds of millions of customers. Okay, so the approach. Warm scenario. Yes, just a primer on the model families for the collaborative latent models that work very well, right, in warm scenarios. So matrix factorization and variance learning, the U and V latent factors, latent factor matrices, shadow and autoencoders, which is very strong baselines that scales very well, and the generative models, which are currently dominating the Netflix and Movieland leaderboards. With the variational autoencoders and their extensions, and also the diffrec model. Sequential models are also, powerful baseline. Lots of work in that direction. There, the loss would not be a reconstruction loss as with latent collaborative filtering model, but rather a binary cross entropy and predicting the probability of click or purchase of one item given the customer and item features. So one observation I made when doing this work is, and there is a Netflix paper on this as well, is one reason behind the success of generative models is that you get some, you reduce the overfitting towards the identity, which is a problem when you are actually training a model with this reconstruction loss. You get this, you reduce the overfitting towards the identity for free with the generative process. And I was just, playing with the regularization strategies, and just by adding this diagonal regularizer to the slim model, I was able to get some interesting lift, right, with respect to slim. So 2 modifications with slims here. You basically have a weighted matrix to weight the positive and negative labels differently, and you have these gamma regularizers to make sure you don't overfit to the identity. And then we saw some lift compared to other linear variants by just using this simple regularizer. So is does something similar, but is does some projection which actually damages Lagrange relaxation that is being done. Okay. So the approach of MARec is an end-to-end learning architecture to learn at the same time, jointly learn the item factorization, the backbone model that is borrowed from well-performing collaborative filtering method, and the merging of the two branches, right, as done in retrieval architectures, right, the backbone model, the collaborative filtering branch, and the similarity branch coming from the item metadata features. It's also a symmetric problem, right? I could do the same presentation for the customer metadata features. Okay, so three functions we are learning. F theta B, which is a latent collaborative filtering model, F phi E, which is the learned item representation. The item representation can be just simple bag of word representation, or can be fine-tuned embeddings on the click data, for instance. And the alignment function, which plays probably the most critical role in this contribution, to basically align the item representation to the collaborative filtering space. And the idea is basically for the items for which or the customers for which we don't have enough click information, we should just rely on metadata information and align them in the same collaborative filtering space, so that the recommendation makes sense and we can get the lift we want. So overall, the loss function is a sum of two terms. L1 loss doesn't mean L1 norm, but I name it L1 here, but it's a backbone model. So it would be the VAE, it would be ease, it would be matrix factorization, and the alignment term, which aligns the similarity of coming from the feature metadata information onto that collaborative filtering embedding space. So this is basically, again, this is a sum of two terms as done commonly in the hybrid collaborative and content-based filtering models. This is because it's jointly trained, it can be seen, and this this is jointly trained with some alignment in the similarity space. It can also be seen loosely as a retrieval augmented architecture. Okay, so the backbone model here in the scope of in this work, right? We stuck to any latent collaborative filtering method. I do think we could extend to sequential models as well, because we can learn useful sequential representation, customer representation, item representation with such models. However, I didn't explore too much in that direction. The embedding model is anything starting from very simple, right? Zero-shot visual and text embeddings, categorical, multi-hot encoded features, TF-IDF. I mean, it could be something very simple, or some learned representation trained on the click data, and the click you have access to in the training set, or some out-of-domain clicks as well. We can extract knowledge-based representations. I mean, we are free to use any embedding models we want. And the alignment model, which is, as I said, important. So the matrix here, DR, will be the regularizing matrix pushing the metadata learned similarities to a large value when the items or the customers have only a few clicks, and will be seriously dampened when the customer has spent a long time on the platform, the item has a longer click history. And this G is important, is a quadratic term, right? Smooth, basically, where here we are learning the second order, it's a second order linear regression, where we are learning the contribution of each sub-feature space to the overall similarity between the items or customers. And the reason we do that is to have some non-linearities that are being captured. And when I say sub-feature space, that would be, for instance, for items, it would be actors, directors, movie descriptions, movie titles. movie genres, etc. Right? Or we could also sample the feature space so that it doesn't exactly match, semantic features, and that works as well. But yeah, that's the idea to have some to mix basically the learning and have first order and second order similarities that are being captured in this alignment term. Yeah, so basically it's very simple addition, augmentation to the well-performing standard collaborative filtering methods. And you can see here with the variable autoencoder MARec VAE, we just had a term to the multinomial log likelihood. So optimizing, the method I'm reconstructing the click history xi, given the sample latent factor from a Gaussian distribution, and this is passed through a multi-layer perceptron, and then we are maximizing the log likelihood function that is here, and the second term that is added here, the bij log pi j zeta a, is actually coming from the alignment term. Similarly with the MARec is, we just have an additional term that is pushing the theta matrix that is learned to the metadata learned similarity representation when the item has very few clicks, and this term becomes close to 0 when the item has a lot of clicks. This has the advantage of admitting the closed form solution.
Julian, I'm afraid the time is up. Could you wrap up, please?
Yes. Yes, so quickly experimental results. So we saw impressive lift with respect to state-of-the-art approaches in cold start literature on various datasets of different characteristics and scales, and lift a range between 10% up to 50% recall at 10. In terms of the ablation study, a few results. Basically, we were, depending on the backbone model used, we were seeing different level of performance, and those features are inherited basically from the backbone collaborative filtering model. We can explain why it's going that way. And by a second important result from the ablation study is that by adding additional metadata information, we were able to get significant boost. In particular, adding the tags extracted from the posters of the movies were leading a very significant boost in cold start performance. So it was a simple yet effective framework for cold start representation. The model transitions to state-of-the-art in warm scenarios, so we don't have to maintain an entire suite of models. This reduces operational load, and we can readily incorporate better and more informative features and more features. More work to be done in the joint metadata learning direction. I think the merging mechanism is a bit naive, and we don't get the same lift you can see in the paper in the mixed scenarios. So we would need to look into that. And also the theoretical analysis on the lift obtained. We have some work going on generalization by leveraging item and customer metadata. Thank you very much.
Thank you so much. We have time just for one question. So a picture is worth 1,000 words, but in your paper I saw that you added, like, for movie lens, I think, like images and tags perform way better than image kind of information. Could you explain intuition, why is that happening?
Yeah, so this, I said it, there is a caveat here. The tags are actually provided by user in the movie lens dataset, right? So this actually is not purely cold start. And this is a limitation, right, that I mentioned, that ideally we should be able to extract those tags from the images themselves, right, and construct these semantic features ourselves, not relying on the customer data. So yeah, there is a little bit of cheating here, right? So that's why the lift is that impressive. Yeah, and the bag-of-word representation in this similarity space, like here for the tags we are using, it's a small vocabulary, and it says a lot about the similarity between movies.
Thank you so much. Let's thank the speaker.